Alors, je vais inviter maintenant Assal Habibi, qui va commencer à nous parler du développement cognitif de l'enfant. Assal Habibi est professeure associée de recherche en psychologie. Elle est directrice du Centre de l'Université de Californie du Sud, University of Southern California, pour la musique, le cerveau et la société aux États-Unis. Elle est venue spécialement de Californie pour nous et je la remercie beaucoup. Elle va nous parler sous le titre, en français, le crescendo du cerveau, comment la formation musicale enrichit le développement neurocognitif de l'enfant. Elle va nous parler en anglais, mais vous avez, je crois, la traduction simultanée. Assal Habibi.
Bonjour, good morning. Thank you, Stan, for the introduction. Thank you, the host of RI Foundation, for having me here. It's such a pleasure to be here with you all and to be able to share my work over the past 10 years or so on the role of music on child development. I come to this question from a personal interest and perspective. I grew up playing Western classical music, and I always recognized the role of music in my own development and emotional maturation, but also the way that it allowed me to connect with society and community. So overall, I'm really interested in understanding the interaction between sociobiological predisposition and engagement with music and how this interaction relates to neural, cognitive, and social-emotional development in children. Today, I would like to share with you evidence from a longitudinal study, some cross-sectional work, and then ongoing work with a randomized control trial and a large cohort study to provide some evidence and to try to convince that music does have benefit in domains that we are interested in, outcomes that we are interested for child development. Okay, so let's start with the longitudinal study. This is a study that I've done since 2012 in collaboration with the Los Angeles Philharmonic and their youth orchestra program. We recruited children. This is not a randomized control trial. We recruited children between ages 6 to 7. They have already enrolled in the program. However, they have not started their training. And then we followed them systematically year after year, had them come to our laboratory and tested them with a comprehensive battery of assessments and tests. You can see one of our participants here. They're all grown up now. They're actually going to college this year. So this is way when they were younger. They were 25 children in the music group. Let me tell you a little bit about the music program. The music program is an El Sistema-based music education program. So they are primarily from underserved communities of Los Angeles, primarily from immigrant families. The program provided free of charge music training and education for them 4 days a week, about 2 hours a day. So it was pretty intense and pretty frequent. It also created a community for them. So somewhere to belong to, somewhere to go to, not being on the street, not being in front of a TV. Because we were going to follow them over 5 years, and we know that every child gets better with language, cognition, and outcomes of interest, we also needed control groups. Our first control group were, let me figure this out, okay. A sports program. These were children from very similar socioeconomic backgrounds and neighborhoods, and they were part of a community sports program, soccer or swimming. Again, free of charge training, and their families were involved in a community of athletic and sports. And then we also had a passive control. Now, this was not a randomized control trial. We did not tell these children in the passive control that for the next 5 years, you cannot touch a piano or a soccer ball. That would not be ethical. We followed them systematically, had conversation with their parents about every 6 months. And at the time of enrollment, they were not participating in any systematic music or sports. But if during the study, they took up music or sports more than 3 months, and equivalent to the frequency of our intervention, we excluded them from our analysis. We continued to follow them, but not in our analysis. So here, I'm just showing you the the timeline of this study and all the tests that we have done. These are psychometric tests looking at musical development, development of cognition, executive function and language, social-emotional health. We also did extensive interviews with their parents to better understand home environment and how they're relating to their families and friends. We use neuroimaging, structural and functional MRI to look at how the brain structure changes how the connection between these structures change and how their brain functions differently. And then use electroencephalography, EEG, to look at kind of passive and auditory perception, both passively and actively. Every other year, they did the imaging. You can see kind of the cohort size at year 1. You can see that up to year 5, we actually had a pretty good retention. This is above 80% retention in the program, which means that they stayed with their music program. Or they were part of the sports, they stayed with the sports. We also had a smaller cohort that continued up till year 7, but most of the result I'm going to be showing you today is between year 1 to year 5. So this is a very large study. I'm not going to give you all the results, but I'm hoping to highlight some of the findings today. Let's start with music training and musical skills. These are the skills that we expected to change. They're playing music, so we hope that their pitch perception and their rhythm perception changes over time. And as we expected, you can see the blue line depicts the music group, and these are year 1 to 5. Sorry, 5 is supposed to go here. The music group significantly performed better and overall got better compared to the sports and control over time. Also, in terms of their musical skills production, how they can sing and how they were able to follow the beat and synchronize their rhythmic perception with another drummer or another person that they had a movement with. On those 2 domains also, the music group over time significantly improved compared to the sports and the control group. So, kind of a sanity check. They're learning music. They're doing better with music perception and music production. Moving on to more auditory perception. So the way that I'm organizing the result is that we're going to start with music, auditory, and then we'll go to more far transfer effects like cognition and executive skills. In a task that during which we collected EEG data, they listened to very short pieces of sound. These could be musical sounds or pure tones, while they were watching a kind of a silent documentary or an animation. And our interest was to see how their auditory perception, does the sound encoding differ in children who learn music compared to the ones who are not learning music. And I'm going to walk you through these. These are event-related potentials. These are global field power, so everything is positive. And I'm going to show you music, sports, and control. The year 1 is depicted in dotted line, and year 3 is in the solid line. And what I want to pay attention to is that compared to year 1, which was the baseline, versus year 3, you can see the appearance of these 2 bumps. This is the transition of the P100, which is the event-related potential depicting that the sound has reached the auditory cortex and is being processed and is being transformed from P1 to N1 in the children in the music group. This is happening when you look at adults, you just really see the N1. There is really very small P1. And it looks like the children in the music group have arrived this milestone earlier in time because we did not see the similar pattern in the sports and control group. Let me show you this these are topography maps of electrophysiology. You're looking at the brain from the top. And basically, the N1 that I show you, you can see it's this kind of blue that is happening in the central areas, and it's getting stronger over time in the children in the music group. Is really not as present. Eventually, by year 4, the sports and control group get to that point. But what I want you to pay attention to is that the music group seems to have arrived to this earlier in time. There was a difference in the N1 amplitude significantly between both groups at year 3 and year 4. Moving on to more an active auditory task, a working memory task. We wanted to know if learning music would help individuals keep information in their auditory memory. Auditory working memory is important. You practice it every day. You go shopping. There is a list that you have to remember. There is a phone number that you have to remember. So it's a skill that you use every day. We had them listen to pairs of melodies. Sometimes the 2 pairs were identical, and sometimes the second pair had a note that was deviant. This deviation could have been a rhythmic deviation or a pitch deviation. And all we asked them was to say whether the 2 parts were the same or different. When the 2 parts were the same, everybody performed equally. So it was not an issue that they cannot hear. When the 2 melodies are the same, they said they were the same. However, when there was a difference, the music group significantly did better at post 2 years and post 4 years of training. And that difference behaviorally corresponded to appearance of this event-related potential P300. This is the kind of the red distribution you see on the frontal central parts of the brain. It is sourced to the anterior cingulate, which means basically allocation of attention to the auditory environment. So when something is going on in their auditory environment that is deviant, that is not expected, not only they can detect it behaviorally, the brain shows a signature of that successful detection. This was compared music to control, and the sports group fall in the middle. They were not as significantly different. The differences came primarily from music versus control. Okay, we learned all about the auditory cortex earlier today. So this is looking at the primary and secondary auditory areas, the Heschel's gyrus, primary auditory cortex, and the superior temporal gyrus, anterior and posterior on the left and the right side. Because these are areas that are engaged with processing music, we wanted to know whether the structure, the morphology of these regions change as a result of music training. So we looked at cortical thickness over time as they learn music, and interestingly, what we found is that in the music group on the right side, over time we saw less thinning of the cortex in the superior part and the posterior part of the superior temporal gyrus. So going back in this area, in the blue area, compared to two control groups. Now, this was kind of not expected. We looked at the language literature, and it seems that very similar thing happens with language learning between ages 5 to 7. There's less thinning of the cortex on the left side because language is left lateralized. To verify these results, we actually went and got a separate cohort of children. These are cross-sectional cohort, completely different, very similar training. 20 of them had music training, and the other 20 did not have music training. Very similar socioeconomic background, and we found the same results. The superior temporal gyrus on the right side was thicker in the music group compared to the control group. But the interesting is that if cross-sectionally we only looked at that, we would think this was just a thickness difference, whereas longitudinally it allows us to look at that the rate of thinning is less. And actually, the cortex, the cortical thickness on the right side was highly predictable of their musical performance skills. So when we had them play music and scored them under production, that was related to their cortex. Looking at how the two parts of the brain, kind of the two hemispheres of the brain were connected, I'm showing you kind of white matter fiber from the top of the brain. This was done through diffusion imaging. The corpus callosum connects the left and the right side of the brain from different regions. And we wanted to look and see whether, as a result of music training, there was more connectivity within the two parts of the brain, specifically in auditory, motor, and sensory regions. So there were three areas: the postcentral gyrus, precentral gyrus, and the frontal part, where we saw more connectivity, more robust connectivity as it's measured by fractional anisotropy in the music group compared to the control groups. At baseline, they were very similar. 2 years later, we already began to see differences in connectivity, which probably indicates some integration of motor and auditory areas. If you think about playing music, you have to coordinate your hands, you have to coordinate auditory motor interaction. The more interesting result was the frontal parts. The superior frontal gyrus was more robustly connected in the music group. The results were replicated 4 years after training as well. The sports group has the same robustness of connectivity in the sensory and motor regions, but not in the frontal regions. We also asked their parents, what do you think about their music training? Now, these parents were invested in the program. Even though they didn't have to pay, they showed up day after day, 3 times a day, 3 times a week. So I understand there is some motivation, but over time, the parents of the children who were in the music program rated them less aggressive and less hyperactive. The sports group had the same commitment, but we don't see the same pattern in them. So this reduction in aggression and hyperactivity was significant for the music group. And sadly, as you can see, it actually increased for the control group. These were children who are not doing any enrichment activity after school. Okay, so we talked about auditory perception, auditory working memory, sensory motor regions. These are all kind of like skills that we expect to change as a result of music training because it immediately engages those parts of the brain. But what about more far transfer effects? What about executive function skills? Executive function skills are a set of skills that are very important and have been shown to be very relevant in terms of like academic success, life success, even social success. Overall, they are kind of the sub-skills of executive function is inhibition, inhibitory control, working memory, and task switching. Inhibition is what you do every day. You don't eat a cookie during lunch, so you can be healthier. You show up to class, so you can graduate. It's a skill that we practice and we do every day, and it's very important to develop it during childhood. We tested this inhibition with a delayed discounting task. You may be familiar with the marshmallow task. You want to have one marshmallow now or two later. So you basically give an individual a larger reward in the future and see if they're willing to wait for that larger reward or wanting to have that immediately. We did this with M&Ms, which is a great reward. Sugar is very successful with testing with children. What I want you to pay attention to is that for the music group, which is here on the left, as the size of the reward get larger, they tend to wait more. So for a small reward, 1 versus 2, sometimes they wait and sometimes they wanted to have the reward immediately. However, when the size of the reward gets larger, which is 1 versus 6 M&Ms, 100% of the time they wait. So they're able to think about it and plan for that future reward and wait for it. We don't see the same pattern in the control group. Sometimes it doesn't matter how large the reward size is. It does not dictate their waiting and inhibition. And again, you can see that sports group falling in the middle, which means that some of these results and findings are coming from being part of an activity that's engaging and rewarding. So some of it is music, but some of it is also being something that is motivational. However, the music group did the best. We wanted to look at this inhibition control inside the MRI scanner and understand kind of the neurocorrelates of that. For doing that, we did a color word stroop task. Basically, you see a word that either is congruent with its color, so the word blue in color blue, or it's incongruent, the word green in color yellow. And your task is always to name the color of the word. So in incongruent versions, you just have to stop yourself from reading the word and name the color of the word. This is a known task to engage inhibition networks in the brain. And when we compare children in the music versus control groups, so I'm showing you music versus control in the incongruent versus congruent, we saw more engagement, stronger engagement of inhibition networks, so dorsolateral prefrontal cortex, anterior cingulate, and supplementary motor area in the music group compared to the controls. The differences between music and sports did not reach significance at this. So at this level, this is 2 years post-training, they were already able to engage their prefrontal areas, which is not something, you don't go to music class to learn inhibition and impulse control. It's kind of a far transfer benefit of music training that we see at that age. So this was age 9 to 10, 2 years post-training. When we did the same task 4 years post-training, only one area survives multiple comparison, which is the right inferior frontal gyrus. This shows to us, and our interpretation is that by this time, the control group gets caught up. They're already there. The music kids get to that milestone again faster and earlier in time. That motivated us to look at all of our data, cross-sectionally and longitudinally over time for these executive function skills. So I'm showing you working memory skills first. This is all of the participants over time, kind of the bins of age. And you can see that for working memory, so the music by group interaction is significant over time. However, you can see the sharpest, kind of the most steepest change happening at an early age. This to me is very important for a policy perspective. The investment we can put in childhood music education and elementary school probably had a lot more benefits than when we just introduced music at high school. As we can see, the biggest change happening here, by age 10, there's a leveling off of this benefits. Similar for inhibition or impulse control. Again, we see changes most between ages 8 to 10, and then after 10, there is some leveling off. Now, does that mean that music is not at all anymore beneficial at age 10 above? Probably not. The measures that we are using may not be sensitive anymore to see the changes, or they have developed other skills that the measures that we have used are not catching those. But the interesting thing to me is that if they are reaching these milestones earlier in time, at elementary school level, if you are better at language, at cognition, at reading, does it serve as a protection mechanism, both, for example, for dyslexia? If you're arriving to an inhibition milestone faster, you probably have more protection against addiction, other impulse problems during middle school and high school. So these are kind of like the results that we are really working on right now to better understand the changes over time. Now, all the children in our program were bilingual because they were primarily from Hispanic immigrant families. The El Sistema program was brought to Los Angeles by Gustavo Dudamel, and he's the director of the LA Philharmonic, and that was a huge motivator for these parents to participate in music. There is representation, somebody who spoke like them, somebody who acted like them, and he's very, very involved in the program. We know that some of these executive function skills are boosted by bilingualism. If you speak two languages, you typically have better working memory, better task switching, and even inhibition. So we wanted to kind of replicate the results using a cross-sectional sample of students who were only monolingual, just English speakers, socioeconomically similar, but monolinguals. So we recruited about 80 participants, 4 musicians and 40 non-musicians. And we did both a visual go-no-go inhibition task and an auditory inhibition task. In the visual go-no-go task, you're supposed to press a button for a purple triangle and stop yourself pressing a button when you see the white square. In the auditory oddball task, you hear sets of tones, and every once in a while, the tone is different. It's a deviant tone. And every time you hear the deviant tone, you have to press the button. The music group performed significantly better than non-music in both tasks. However, their performance was more significantly different in the auditory, which makes sense because their auditory system is getting trained. So maybe there's more robust differences in the auditory system. In terms of the underlying neural activity, looking at the visual perception, in terms of encoding of the visual stimuli, we didn't see any differences between the groups. However, when we looked at the response, is that the response, kind of the error-related response, after they made a mistake, the music group showed higher amplitude of this error-related response compared to the control group, indicating that they are aware that they made a mistake. For any of you who's a musician, when you make a mistake on an instrument, you immediately know, and that's a skill that you kind of improve. So it was very nice to see that with the event-related potentials. In the auditory domain, however, we saw larger N1 amplitude, again, back to the N1 that I explained at the beginning, so more robust kind of encoding of the sound within the auditory areas, and larger P3. P3B, again, is kind of allocation of attention to the auditory environment. You can see the N1 difference that reaches significance. The P3B doesn't, but it's on a trend, and it highly predicts their performance on the task. Now, everything I've showed so far has not been a randomized control trial. Gold standard research is randomized control trial, meaning that you just put children or participants without their decision into a program so you can eliminate predisposition, motivation at home. We tested our children in the longitudinal study at baseline, but we could not eliminate what's going on at their home environment. So when you do an RCT, it allows to kind of like balance that between groups. So 2 years ago, this is an NIH-funded study, we recruited 40 participants, 6 to 8-year-olds, again from underserved communities of Los Angeles, and we basically told them half of you are going to go to a drama program, and the other half are going to go to a music school. And after 2 years, we're going to assess and see how many of you are still in the program. If it's successful, we're going to add a cohort. We are just now at year 2, they're finishing in May, and I'm frankly surprised and delighted that 19 out of 20 kids in each program still go to the program. This is a lot of work for these parents. Some of these parents take 3 buses to make it to the program. But again, from a policy perspective, if you provide quality art and music education, parents make an effort to participate. So now that we have made our feasibility, so 90% and above are in the program, we have about 96% participation rate. We are adding a second cohort, another 70 participants, gonna follow them for 2 years. They're doing neuroimaging, and our outcomes are inhibition, and both in terms of affective inhibition, like delayed discount that I showed you, and also cognitive inhibition, like a stop signal task. And then we're gonna look at the cohort together at about 110 participants after 2 years. And finally, there is a large cohort study that is happening in the United States. It's called ABCD, Adolescent Brain and Cognitive Development. These are 10,000 children who are being followed for 10 years at 10 sites. All of them are being tested with what is called the NIH Toolbox, which basically assesses cognition and executive function skills. Thanks to one of our colleagues, John Iverson, a music measure was added to this cohort. So it's not an intervention. We are not putting them through a music program, but we're getting information from them of how much music they do at home. It's a self-report, and it's basically kind of like divided into whether you have music at school, whether you have music at home, how much you practice, frequency over time. And the baseline scores are between ages 9.5 to 10 years old, and about 10,000 kids. All these results are adjusted for race, ethnicity, and socioeconomic status. And I just went, and you can access this data, it's publicly available, and I looked at the executive function outcomes in children who have indicated that have music versus the ones who have indicated that they have no music. And in every outcome in the executive function, the music group perform highly significantly better than non-music children. So this involves reading, task switching, picture matching, pattern recognition. And when we actually, when I put them all together and kind of like got a cumulative cognitive score and then adjusted the other group, the non-music group, for other activities, enrichment activities they do, like playing soccer, other types of sports, being part of a visual arts program, the results remain to be significant, when even adjusted for other programs. Now, I haven't compared one-to-one, like music versus visual arts. I think child development is a whole concept, and we should not be saying only music is good and only visual arts is good. Children should be exposed to these different options and have a good quality training so they can make a decision of what is best for them. So, with that, I wanted to just kind of like summarize and see that my work over the last 10 years or so have provided evidence on both kind of longitudinal perspective and cross-sectional perspective that there are benefits of music training for executive function skills. Generally, these skills are more pronounced in the auditory domain, and auditory-related executive skills, such as working memory, auditory working memory. However, we also see benefits in general, kind of like visual go-no-go task. This relationship specifically between music training and executive function seemed to be leveling up at age 10. And I already said that doesn't mean that music is no longer helping. It's probably not as sensitively measured. And again, kind of arriving to those milestones faster in life may provide some protection and put you at an advantage compared to your counterparts when you're in a school environment. I'm hoping that our randomized control trial can answer this question a little bit more systematically because it's the same age range that we are looking at. Knowing all of this, in California, which is one of the more progressive states of the United States, up to last year, the ratio of a music teacher to students was about 700 students to one teacher. If you have ever tried to teach a bunch of 6-year-olds violin, I don't think more than 4 or 5 would work. 700 it's a number that is at all not practical. But I'm really happy last year in California we passed a proposition, it's called Prop 28, that has earmarked art education and music education for every child in every public school. So once it is unrolling and hopefully successfully, every child that is in the public school program will have access to music, and it's a really good opportunity from a research perspective to follow these children and see access to that quality music program, how it changes for them. And with that, I would like to acknowledge my lab and my students and collaborators and all the funding partners, and thank you for your attention. Happy to be here.